the basics of RBC morphology. So what is hemoglobin? Hemoglobin is heme plus globin. And what is heme? Heme is iron plus protoporphyrin. तो anemia कब हो सकता है if you see? If your iron is deficit or if there is some defect in the heme synthesis. So what happens? Iron is incorporated into the protoporphyrin at the last step of heme synthesis, and that step is being catalyzed by enzyme ferrochelatase, and so this ferrochelatase is a target for lead and very other defects also. So when can you have anemia? You can have anemia when the body is very deficit of iron. So you can have iron deficiency anemia characterized by microcytic hypochromic anemia. What can happen in this? Also that iron is present in excess in the body, but it is unable to be utilized. And when can this happen? It can happen in anemia of chronic disease, classically happening in conditions like rheumatoid arthritis. इसमें हो क्या रहा है? The body has increased inflammatory markers, namely interleukin 6, that will stimulate your hepcidin. And what is hepcidin? Hepcidin is a systemic regulator of iron absorption. सो हेप्सिडिन को क्या सिग्नल मिलता है कि बॉडी में आयरन तो बहुत एक्सेस में है, उसको एब्जॉर्ब मत करो. तो आयरन तो है लेकिन आयरन हीमोग्लोबिन नहीं बना रहा, एंड दैट इज व्हाई यू आर हैविंग अनीमिया. नाउ व्हाट हैपेंस इन porphyrins और lead poisoning? We all saw the last step of ferrochelatase where iron is going to get incorporated into protoporphyrin. This is defective in both of these conditions. So what is going to happen? Iron is in excess in the mitochondria because these steps of porphyrin synthesis or heme synthesis are happening in mitochondria. So iron is in excess in mitochondria, but the iron is not being utilized to form hemoglobin. So you will have iron deposited in the mitochondria as ring form around the just like as in they are getting deposited, and these cells are called as ring sideroblast. Ring sideroblast are characteristic of lead poisoning or sideroblastic anemia, and they in certain conditions like MDS they are also associated with a mutation called as SF3B1 mutation. That can be a question for you. So if you notice in all of these conditions, if you do the iron profile, the iron is deficient only in iron deficiency anemia. सिर्फ इसी में iron भी कम होगा और stores भी कम होंगे. In all rest of the conditions, iron is in excess. So serum iron is going to be low, but what is going to happen? You will have excess of serum. You will have increased serum ferritin, and you will have decreased total iron binding capacity. What is total iron binding capacity? It is the thirst of your body or the thirst of the transferrin molecules to have more of the iron molecules and transport them. ये thirst कब बढ़ेगा? जब iron में deficiency होगी. But जब iron already body में excess है, so this thirst goes down. So TIBC is normal or decreased in rest of the conditions, whereas it is increased in iron deficiency anemia. Now what happens in hemoglobinopathies? Hemoglobinopathies, as the name suggests, some defect in the globin gene. अब globin gene को देखो, they are having two beta gene which are located in chromosome 11 and two alpha gene which are located in chromosome number 16. So beta gene are going to encode for all of these molecules. Epsilon in the embryonic stage, gamma chain, delta chain and the beta chain, whereas alpha chain are going to encode for zeta chain and alpha gene. So what happens in adults? Yeah, in embryonic we start with embryonic hemoglobin encodes for only epsilon and zeta. So your embryonic hemoglobin has epsilon and zeta chain from beta gene and alpha gene. ठीक है, embryonic तो खत्म हो गया, हम तो है नहीं embryonic में. Then comes what? The adult hemoglobin more than 97% is composed of beta chain and alpha chain. Okay, this we all know. Small proportion of it we also have HbA2, which normally should be less than 3%. उसमें क्या gene combination होता है? You have delta chain and alpha chain. So this delta and alpha are present in HbA2. All of them are adult hemoglobin. Now what happens in this? This gamma is left. This gamma is present in combination of gamma and the alpha chain. Gamma and the alpha chain is present in fetal hemoglobin or the HbF. So your HbF is more than 90% till 6 months of age, but after 6 months this HbF goes down drastically. So when HbF is present, we have a condition which we are going to discuss next. So we are clear, the adult hemoglobin is beta alpha, the other HbA2 is delta and alpha, and the fetal hemoglobin is gamma and alpha. Is that clear to us? Now what happens? Alpha or beta globin chains hai. What is happening? You need to have all of these conditions we are going to talk about. Thalassemias where alpha chain is affected, and these are alpha thalassemias. Beta thalassemias where the beta gene is affected, we are going to discuss next. So what happens in alpha thalassemia? अगर सिंगल जीन में दे आर कॉज बाय डिलीशन, ठीक है. इफ इट इज अ नॉन डिलीशनल, डिलीशन मतलब कुछ कोई जीन जो है वो टूट के डिलीट होने वाला है, ठीक है, दैट इज कॉल्ड एज डिलीशन. सो अल्फा थैल कैरियर जो होता है उसमें यू कैन हैव अ सिंगल जीन का डिलीशन, साइलेंट होता है, कुछ भी नहीं होगा. अल्फा थैल ट्रेट विल हैव 2 जीन डिलीशन, उसमें भी कोई प्रॉब्लम नहीं होगी. प्रॉब्लम कम्स इन हेयर HbH वेयर यू हैव 3 जीन डिलीशन. और क्योंकि द पेशेंट इज सर्वाइविंग टिल एडल्ट्स, ठीक है, ये एडल्ट स्टेज में हिमोलिटिक अनीमिया के साथ द पेशेंट प्रेजेंट्स. एंड एडल्ट हीमोग्लोबिन हमारा कौन सा होता है, ठीक है, बीटा होता है, अल्फा होता है. अल्फा जीन में डिलीशन होगा. सो व्हाट इज गोइंग टू फॉर्म इन एक्सेस? बीटा 4 टेट्रामर्स. इज अ वेरी कॉमन इंपॉर्टेंट क्वेश्चन. वी नॉर्मली डू गेट कंफ्यूज, बट दिस इज द कंसेप्ट बिहाइंड दिस. एडल्ट्स में हो रहा है, इट इज नॉट अ फेटल कंडीशन. So it is going to have adult counterpart के tetramers, that is beta 4 tetramers, and a very important inclusion that is called as the golf ball inclusion. And these golf ball inclusion, they appear like golf ball, dot 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 over this ball. They are not seen in the Giemsa stain. They are seen where? They are seen in supravital staining, crystal violet or methylene blue, जिस जो staining we do for reticulocytes, ठीक है, उसमें you are able to see these inclusions. नाउ अब 3 जीन डिलीट हुए थे, अगर चारों के चारों जीन डिलीट हो जाएंगे तो व्हाट विल हैपन? द कंडीशन इज इनकम्पैटिबल विद लाइफ. इट हैपन्स इन ड्यूट्रो, द बेबी इज बॉर्न डेड. सो इट इज हाइड्रॉक्स फिटालिस एंड इट इज कॉल्ड एज हीमोग्लोबिन बार्ट्स. तो हमने पढ़ा था कि फीटल लाइफ में क्या होगा, ठीक है, और कोई हीमोग्लोबिन तो है नहीं, गामा बचा हुआ है. सो व्हेन द अल्फा जीन इज lost, gamma is left, and it is going to form gamma 4 tetramers, and that is why hydrox fetalis will have gamma 4 tetramers, HbH will have beta 4 tetramers. And if alpha gene में no deletion is happening, non-deletional alpha thal is called as hemoglobin constant spring. That becomes a hemoglobinopathy. Now what happens when the beta gene is affected? Beta gene, as we all know, has various codons, ठीक है. Thalassemia we are going to talk next about. There are various codon, namely being codon 6 and codon 26, ठीक है, which are important for you. तो codon 6 पे and codon 26 पे the amino acid which is present is glutamine. Glutamine is a normal amino acid. When the missense mutation, please remember what is happening. The missense mutation is happening and the glutamine is going, and what is coming? If valine comes at the codon 6, it is going to lead to sickle cell disease. But if at codon 6 glutamine goes and lysine comes, then it is going to form HBC disease. Okay, please remember this. Glutamine to valine is sickle cell disease. Glutamine to lysine, ग्लूटामिन ही रहेगा हर जगह. ग्लूटामिन जा रहा है और कुछ और आ रहा है, तो जब लाइसिन आएगा तो क्या बन जाएगा? HBC डिजीज. देखो L और C एक जैसा है, L और L को कर्व कर दिया तो C बन गया. तो प्लीज रिमेंबर दिस. एंड कैरेक्टरिस्टिक, यू कैन हैव सिकल सेल type RBCs as you all know, and HBC का characteristic होता है you get these crystalline inclusions within the cell. What are these crystalline inclusions within the cell? Now next talk what this was codon 6. If codon 26 comes, and what is happening? Glutamine is going and lysine is coming, same, लेकिन different codon पे हो रहा है. So क्या hemoglobin बनता है? Hemoglobin E is happening, ठीक है. So you will have a hemoglobin E, hemoglobinopathy. Now next come to what is going to happen if there is no missense mutation but frame shift mutation happening in the intervening sequence. We have 3 exons and 2 introns in this beta gene, ठीक है. सो जो एक्सॉन और इंट्रॉन के बीच में जो इंटरवीनिंग सीक्वेंस होती है ना, उसमें फ्रेम शिफ्ट म्यूटेशन होती है मोस्ट कॉमनली इन दी 41-42 एक्सॉन या कोडॉन के बीच में फ्रेम शिफ्ट म्यूटेशन. देन थैलेसीमिया इज हैपनिंग. So you can have condition of thalassemia trait when only the one allele of the gene is being affected, or thal major, ठीक है, where completely the hemoglobin A is absent and you are having increased HbF. That condition is called beta thal major, where you will have all the conditions of hemolytic anemia. You will have hepatosplenomegaly, you have frontal bossing and hemolysis. Whereas beta thal trait is a carrier condition where the patient will have microcytic hypochromic anemia, but the HbF is not increased, HbA2 is increased. This condition will not have any features of hemolysis and the patient would just be a